All right, children, I've shared the presentation on circles. Is it visible?
Yes, ma'am.
Yeah. Okay, so we'll quickly see the answers to this one. Arithmetic progressions, I've already prepared the answers, so that I'll share it live with you. You can check it yourself. And then we'll take up the next one for today's class from triangles. Yeah, okay. So you know the questions, so I'm not reading it for you. I'll just directly go to the sub questions. I'm not reading the case study. The measure of angle OSA is, the measure of angle OSA is 90 degrees, correct?
Yes, ma'am.
Yeah, which of the following is correct?
Yes, ma'am.
Yeah, which of the following is correct? AS is equal to AP, correct? BP is equal to BQ. BP is equal to BQ, correct? CQ is equal to CR. CQ is equal to CR, correct? So which is the correct option? All of these. Yeah. DR is 7. AD is 11. AD is 11. Then AP is equal to. So if this is 7, this is 7. So 11 minus 7, this is 4. Which means AP is 4. Correct?
Yes, ma'am.
AP is 4. If there's any difference with our answers, let me know. And the fourth one, QCR is 60 degrees. QCR, this one. QCR, excuse me. QCR is 60 degrees. Then QOR, QOR, this angle. So we know that this is a cyclic quadrilateral, right? This one is a cyclic quadrilateral. So opposite angles are supplementary. So this will be 120 degrees. Let me show you like this. Circle. Tangents from an external point. So if this is 60 degrees, this angle will be 120. Same thing here. You can see the external point. This is the external point. These are the tangents. So it's this kind of a situation. Opposite angle is supplementary. So angle QOR is equal to 120 degrees, correct?
Yes, ma'am.
There's 60, there's 120. Or you can use the angle sum property in a quadrilateral. You can say this is 90, this is 90. So by the angle sum property of a quadrilateral, it's 120 degrees. Okay, which of the following is correct? So we know that when a quadrilateral circumscribes a circle, the sum of the opposite sides are equal. The sum of the opposite sides are equal. So that means AB plus CD is equal to BC plus AD. The sum of the opposite sides are equal. So AB plus CD is equal to AD plus BC. This one is the correct option, correct? This, you should remember this. When a quadrilateral circumscribes a circle, the sum of the opposite sides are equal. The sum of the opposite sides, AB plus CD, is equal to BC plus AD. Is that correct, children?
Yes.
Yeah. Are you there, Florentina? Okay, a line that intersects a circle exactly at 2 points is called a secant.
Secant.
Yeah, number of tangents that can be drawn on a circle is
Infinite.
Number of tangents that can be drawn on a
Infinite.
circle. Yeah, Danya, who was that who answered?
Infinite.
Yeah, correct. No. Okay, Danya. Then Florentina, what's your answer? Okay, infinite. Because on the circle, number of tangents that can be drawn to a circle, sorry, number of tangents that can be drawn on a circle. On a circle, you can draw many tangents. You can draw many tangents. Infinitely many tangents. Number of tangents that can be drawn to a circle from a point, not on it, is okay. Not on it means it's not inside or on it. No, number of tangents that can be drawn to a circle from a number of tangents that can be drawn to a circle from a point, not on it. Not on it meaning it's not a part of the circle at all. Number of tangents that can be drawn to a circle from a point, not on it. Meaning the point is not a part of the circle at all. That means it's outside the circle. Even if the point is inside the circle, it's like on it, right? It's a part of the circle. See, you need to understand the question the best possible way, sometimes. So here in this context, it means the point is not on the circle. That means it's not a part of the circle, which means it's outside the circle. Then how many tangents can be drawn? 2 tangents, right? The point is not on it. The point is not on it. That means the point is not a part of the circle at all. It's not inside or on the circle. It's outside the circle. It's not on it. It's nowhere on the circle. So it's not a part of the circle. The point is not a part of the circle. So that means it's outside the circle. 2 tangents can be drawn. Number of secants that can be drawn to a circle from a point on it. So you take a point on the circle. Number of secants that can be drawn to a circle from a point. Yeah, infinitely many. So you can draw. Yeah, you can draw a secant like this. You can draw a secant like this. You can draw a secant like this. So number of secants that can be drawn to a circle from a point on it. When you take a point on the circle, you can draw infinitely many secants to the circle. So this is the answer. As a line that touches the circle at only one point is called
Tangent.
Tangent. Very good. So I said I'm not reading the case study because you all know the situation. So I'm just reading it for myself and marking it. So this one will be 6 minus x. This whole thing is 6. This whole thing is 8. This one is x. So this one is x. So this part will be 6 minus x. So that means this part also will be 6 minus x. Then this one will be. This one will be 8 minus 6 minus x. So it will be 8 minus 6, 2 plus 6. Sorry, children. All right, so what do we have to find now? So if this is 2 plus 6, I'm just marking all that as, like possible. So this also is 2 plus x. This one. Okay, so we're given this is x, so this is x. The whole thing is 6, so this is 6 minus x. So this is 6 minus x. But the whole thing is 8. So the rest of it will be 8 minus 6 minus x. which is 2 plus x. So it's 2 plus x here also. Now let's answer the questions. The value of AR is equal to x, correct?
X, ma'am.
The value of BQ, correct?
6 minus X.
Yeah, CQ. The value of CQ is
2 plus X.
correct. Then which of the following is correct? Which one is a square here? This one, right?
BROQ, ma'am.
Correct. Where is it? It's here. What about the others? What about AROP? What is AROP and CQOP? What special name can you give these two quadrilaterals?
Cyclic quadrilateral.
Sorry?
Cyclic quadrilateral.
Cyclic quadrilateral. Very good. Still another special name?
Kite, ma'am.
I'll just put myself on mute if I'm, like coughing too much, all right? So excuse me. Yeah. Yes, Raja is right. It's a kite. The quadrilaterals can also be called kites. So this one, this one is a kite. Because adjacent sides, two pairs of adjacent sides are equal. It is a cyclic quadrilateral. It can also be called a kite. Similarly, this one, ORPA, this one. Kite. All right. And the radius of the pit is? What's the radius of the pit? So is equal to 10, correct? We need to find AC using Pythagoras theorem. We need to find AC using Pythagoras theorem. So x plus 2 plus x is equal to 10. So 2x is equal to 8. X is 4. Correct?
Yes, ma'am.
Okay. We need to find the hypotenuse. 6, 8, so 10. Then x plus 2x is equal to 10. Yeah. So we'll first find, we'll join this, So this one is 13. Pythagoras theorem, this is 13. It's 5 here, so it'll be 8 here. It's not proportionate, so we'll ignore that. Because this little thing is 8, but this one is 5. That's okay, just ignore it. Load again. So 12, this is 12 children, and this is 5 radius. This is 5. Radius is 5. So the hypotenuse, 13. 13 minus 5, 8. So this one is 8. Now the radius is 4. Radius 4. So the hypotenuse BQ will be 5.
5, ma'am.
5. But this is 4. So this will be 1. 3, 4, hypotenuse is 5. The hypotenuse BQ is 5, but the radius is 4 here. BY is 4, so YQ is 1. Okay, now let's answer the questions. Find the value of PA. PA, 13, correct?
13, ma'am.
Yeah, next one, BQ.
5 centimeter.
5. PK.
18, ma'am.
PK is, this one is 5, right? This one is 5, radius 5. So 13 plus 5, 18. Yeah, next. QY.
1 centimeter.
1. Okay. So in the last one, okay, so we have PA square, PA square, PA square, TQ square, TQ square. Okay, so we'll work PA square and TQ square. We'll work PA square and TQ square, okay? We have two expressions for PA square and for TQ square. All right. So PA square is equal to hypotenuse PA square. I'll just work it. I'll put myself on mute and work it, children. Yeah, children, I hope you followed from the way I was working. We can substitute for the radius in, a few ways, like in the small circle, radius, the line segments that represent the radius are AS, AX, and AK. And in the small circle, we have BY, BT, and BK. All these represent radius. So you can substitute, accordingly. Like when it is addition, you should substitute, like if you have a line segment like this, if it's addition, extend it. When it's subtraction, you should substitute in a particular way. See here, I'll tell you. So here for AS, AS, PA plus extend it, AK, so that you can write it as PK. But here for AS, PA minus, right? So write a line segment on PA itself. Only then you can subtract. When it is PA plus something, when you're adding, write a line segment not on it. Not on it. Only then you can add. But if it's subtraction, write a line segment on it itself. So when it is PA plus AS, PA plus AS, AS is the radius. So A is the radius. So PA plus AK, so that you can write it as PK. But when it is minus, PA minus AS. So PA, and what is the radius on PA itself? AX. So you can subtract PA minus AX is PX. So simply use Pythagoras theorem. And then A square minus B square is A plus B into A minus B. And as we just understood, we can substitute, three line segments for the radius. AS, AX, AK in the first circle, BT, BQ, and BK in the second circle. So substitute accordingly. So here we write BT as BK. So that BQ plus BK will give us QK. And here when it is minus BQ minus BT, BQ minus BT, we write BT as BY because it's on BQ. So you can subtract. BY is on BQ. So when you subtract, we'll get the remaining part of BQ, which is YQ. So now when you check your results with what options you have. So we have worked PS square and we have worked TQ square. So we have PS square here, PS square, this one, and TQ square. So which of the results match QK? I think this one. The third one, right, children?
Yes, ma'am.
Okay, you can take a screenshot. Just in case you have not done it, you can just take a screenshot. Yeah, number of tangents that can be drawn to a circle from an external point.
2, ma'am.
2. Which is the rule here? Conference rule?
Triple S, ma'am.
Okay. Okay, so see the, the activity. Do you see here the student Prem? He's marked the points here. Can you see that? He's marked the points on the straw and then he's spreading the straw. So there's an activity without, like any, without working it through congruency, without actually using, the property of congruent triangles. Using this activity, he understands that the tangents from an external point of the circle are equal. And look at the activity. He's folded the straw and he's fixed the straw here using a nail. He's fixed the straw here using a nail. Or he's taken 2 straws, I think. Okay, I thought he's folded the straw. Okay, he's taken 2 straws. He has taken 2 straws. Okay, so he's nailed the 2 straws like this. So this is like the external point. All right, and he's marked off the points here. You can see he's marked, and then he's spreading it open. He's spreading it open. So you can see these marks here. You can see the mark here, and here. So he knows that this length is equal to this length. He knows because he had already marked it. So this is the tangent at A and this is the tangent at B. And he knows that these 2 tangents are equal because see, he had marked it already. And then he spread it open. So he knows PA is equal to PB. And the criteria. So to see here through this activity, we are trying to understand that the tangents are equal. So you cannot you cannot use PA equal to PB because this activity itself is to understand that PA is equal to PB. The activity itself is to understand that PA is equal to PB. So when you prove that the triangles are congruent, you cannot use this as an information. So it is not SSS then. It cannot be SSS. You cannot use this information because the activity itself is to understand that the tangents from an external point of the circle are equal. Okay, so we cannot use this as an information. PA is equal to PB, we cannot use. So then it cannot be SSS. Okay. So definitely we can use this one, 90 degrees we can use because see, if we are trying to understand it's 90 degrees, then we cannot use that information. So he can use this 90 degrees. Then this one, yes. And this one radius, yes. So it should be RHS. RHS. Not SSS. SSS is when you say that this is equal to this. This one is a common side. And this side is equal to this side. Then it is SSS. But we cannot use PA is equal to PB. So it's not SSS. And then to check SAS, common side, then radius. Then only if you see this angle is equal to this angle, but that comes later. That is equal tangents subtend equal angles at the center. But in this activity, we are trying to understand that the tangents are equal. So we cannot use that property that equal tangents subtend equal angles at the center. That follows this result. Once you understand that PA is equal to PB, then equal tangents subtend equal angles at the center. So angle 1 is equal to angle 2. Now you cannot use that information. Because here we are still here that the tangents are equal in length. Once you understand that, after that, we can prove that this angle 1 is equal to angle 2 and also this angle 3 is equal to this angle 4. Equal tangents are equally inclined. So angle 3 is equal to 4 and equal tangents subtend equal angles at the center. So angle 1 is equal to angle 2. All that comes after we understand that PA is equal to PB. So it cannot be SAS or ASA also. Though we know that angle 1 is equal to angle 2 and angle 3 is equal to angle 4, these results follow the result PA is equal to PB. Only when we know this, after this we understand that Equal tangents are equally inclined to the line segment joining the center and the external point. That is, angle 1 is equal to angle 2. And we also understand that equal tangents subtend equal angles at the center. So angle 3 is equal to angle 4. So now we cannot use that result because we are still here. PA is equal. We are trying to understand that PA is equal to PB. So these results we cannot use. 90 degrees you can use. So then how can it be ASA or SAS? So please think about it. It has to be RHS.
Yes.
Yeah, ASA means two angles and the included side. Two angles and the included side. Now two angles we don't have, no, we can't use this angle and this angle we can't use. We have only one angle. So it cannot be ASA. SAS, okay, SAS, we can use only this side and this side because this side we cannot use. That's what we are trying to prove. This side is equal to this side. So we can use this side and this side. And this is the included angle. This one is the included angle. No, but that information we cannot use now. So it cannot be SAS. It is not SSS, so it is RHS. AOB is 150. APB is 30, right?
30 degrees.
Yeah. APB is 40.
20, ma'am.
BAO. This angle. So this angle, BAO is this angle. This angle. So we know that this is 90. 40. So 180 minus 40. 140. So it will be 70 here. 70 here. So 90 minus 70. This is 20. Because this is an isosceles triangle. These two sides are equal. So 180 minus 40. 140 by 2. 70, 70. But this one is 90. Between the radius and the tangent is 90. So 90 minus 70. This is 20. Yeah, for the last one, the answer for the last one. PAOB is a square. It will be 90. Yeah, what have you selected? Yes. Danya?
D, all of these.
All of these. Okay. So AP is perpendicular to BP. AP. Okay, this one is 90. Oh, sorry. ABO is 45. ABO. Okay, so if this is 45, this will be 45. If this is 45, since this is 90, this one will be 45. So this is 45. So then this is 90. Then this is 90. Not in this figure. This is a different situation. OK, so this one is 90. This one is 90. So AP is perpendicular to BP. Yes, because it's 90. AP is perpendicular to BP because it's 90. Then AOB is 9. Let me check this one. AOB 90. AOB 90. Correct. Opposite angles are supplementary. So this is 90. Correct. PAOB is a square. Yes, it is a square because every corner is a right angle and adjacent sides are equal. So it is a square. This one here, it doesn't look like a square, children. This is a different situation. If this angle is 45 degrees, so don't apply it to the shape of the quadrilateral is not this. Okay, so this is 90 degrees. This is 90, this is 90. So this also will be 90. And so in this, every corner is a right angle, so it's a rectangle, and adjacent sides are equal. So it's a square. It is a square. So this also is true. Everything is true. So all of these. Everything is true. If AB was 45 degrees, all of these are true. This is true. This is true. And this one is a square is true because every angle is a right angle. In the quadrilateral, every angle is a right angle and adjacent sides are equal. So it is a square. Children, just give me a minute. I'll just present a different slide for you. Just engage yourself with that. I'll just come back in 5 minutes. Yeah, please try this one, children. Give me 5 minutes. I'll get back. Is it over, children? Okay, take a screenshot. I don't know, maybe some of you finished. Take a picture. I'll take you to the next one.
Taken one.
Yeah. Yeah, thank you, children. We'll go back to the discussion on circles. Yeah. Okay, I think I'll mark it in this figure itself. AB is a tangent at B. AB is a tangent at B. AB is 10, OB is 5. Then OA is equal to, how much is OA, children? First one. First one.
5.
Okay. So this is OA is the hypotenuse. So 100 plus 25. 125, square root of 125, which is 5 root 5. Correct. 5 root 5. Second one.
8
Yeah, how much is-
centimeter, ma'am.
8. Correct. 8 is correct. Second one. Pythagoras theorem. Next one.
24, ma'am.
24. Correct. Pythagoras theorem. 24. Correct. Next one. PT is a tangent. I'll just mark it in this figure itself. PT is a tangent. We're doing the fourth one using this figure. PT is a tangent. Diameter is 40, so this is 20. PT is 21. Then OP is equal to, how much is it?
29.
29. Correct. 29. Pythagoras theorem 29. Yeah, so here also you just have in the last one use Pythagoras theorem. It's just like this. X plus 2 the whole square is equal to 8 square plus x squared. So x squared plus 4x plus 4 is equal to 64 plus x squared. X squared cancels. So 4x is equal to 60. X is equal to 15. Correct, children?
15, ma'am.
Yeah, but we have to answer what the length of the tangent is. Okay, the length of the tangent is also 15 only. Correct?
Yes, ma'am.
Yeah, Pythagoras theorem again. X plus 2 the whole square is equal to 8 square plus x squared. So when you're expanding, we'll have to be careful. We shouldn't miss the middle term. A squared plus 2ab plus b squared. Okay. So the first one. In two concentric circles, a radius 3 and 5. Okay, so this is 3. Okay, so this is that figure. So this is the chord to the outer circle and a tangent to the inner circle. 3, 5. This is the radius. This line segment represents the radius of the outer circle. This one represents the radius of the inner circle. So the length of the chord will be 4 plus 4, 8. Correct?
Yes, ma'am.
Yeah. Next one, PB is equal to
4 root 10, ma'am.
okay. So it's again Pythagoras theorem. PA is 12. This one is 5. This is 90 degrees. So you get 13 here. Now this is 90. And this is 3. So 169 minus 9. 160 root 160. 4 root 10. Correct. 4 root 10. Right?
Yes,
Yeah,
ma'am.
that's what I heard. Yeah. Then AB is equal to
2 centimeters.
2, ma'am.
2. Okay, from X, PA and PB are drawn to these circles. PA is 6, PB is 8, all right. OP is 10, OP is 10, okay. AB. But why so much of information for AB they've given? Okay, children, tell me, is ABP a right triangle?
Yes, ma'am.
No, ma'am.
Yeah. Oh, okay. No. ABP. Is it a right triangle?
Yes, ma'am.
Yeah, even I agree that with that, because isn't this 90? OA is the radius,
Yes,
right?
ma'am.
OA radius, AP tangent. So isn't this 90? So ABP is a right triangle. ABP.
Yes, ma'am.
Okay, now BP is given, right? No, I don't know. I'm not comfortable with this question. So we'll just do it together so that we come to the right answer. So this one is given, right? PB is given 8. Okay. Then this one is given 6. So if you try to find AB, you will not get any of these answers, no? It can be determined, not that it can't be determined. It can be determined. So this is not the answer, but we can't get any of these. But we can get one of these answers in a different way. So the values are not right, I suppose. Okay, let me see if, like we agree on this. Now, children, is ABP a right triangle? Yes. Now the hypotenuse is 8 and one side is 6. So then AB, using this, AB will be what? AB will be square root of 64 minus 36, right? What is that? Yes or no, children?
Yes, ma'am.
Ma'am, but if you take the larger triangle,
Yeah, that's what I'm saying. But if you take the larger triangle and find OA and the smaller triangle and find OB, then we'll get one of these options. Correct?
yes, ma'am. Yes, ma'am.
Yeah, so now here we have to work it like that. That's all. But the values are not correct. They're incorrect. Meaning the situation is not possible because you should be getting the same answer both the ways. So we can find AB like this. It would have been better if they did not give us the value of OP. If they didn't give us this, it would have been better. We could have just found AB using 8 and 6. Okay, so now when we do this, you cannot choose it because our option is not here. You cannot say can't be determined because it can be determined. So this is not the answer. So that means you should, let go this method and use this one. Find OA, then find OB, subtract and find AB. Okay, so OA will be, this is 6 and this is OP, 1 minute, 10. Okay, so this one is 8. So OA is 8. And then you'll get 6. So 8 minus 6, 2. Correct. Somebody said this. 8 minus 6, 2. You have to do it like this, right?
Yes,
Yes, ma'am.
That is when simple Pythagoras theorem. That's all. When you work OA, the OA you get 8, and then when you work OB using Pythagoras theorem, you get 6. This is 90 degrees. Radius, tangent, perpendicular. This is 90. Radius, tangent, perpendicular. See, you can understand from this itself that the situation is not possible because can you see there's a 90 here? That means what I'm trying to say is it O is a center? Yeah, that's what. So this one cannot be the radius. OA and OB, they cannot be collinear. OA and B cannot be collinear points. All right, children, that's what this figure is incorrect. The information provided is incorrect, but we'll just finish it like this. OA 8, OB 6 by Pythagoras theorem. So 2. 2 is the answer for this. If we have to choose one of these 4 options, then we have to select 2. We are forced to select 2. Because if you see here, if O, B, and A, they are collinear, if they're collinear, you can see that this is 90 because radius, tangent, perpendicular. Here also this is 90, radius, tangent, perpendicular. How is it possible? Because if this is 90, this is 90, no, then in the triangle, this itself is 180. This one is 90, this one is 90. So that means this is 90. That's not possible. Okay. Next one, children, find the length of BP.
Eight centimeter, ma'am.
Okay. BP is the chord. So I think it's enough if we find half BD. Okay. So this one is 3 and this is 4. This is the radius of the inner circle. This is the radius of the outer circle. Radius of the inner circle, radius of the outer circle. Diameters are given. Diameters are given. So the radius of the inner circle is 3. The radius of the outer circle is 5. From the diameters 10 and 6, 5 and 3. So you can find, now this is 90 because, why is this 90? What's the reason?
Ma'am, because angle P is 90.
Because
Angle P is 90.
Radius perpendicular to tangent.
radius perpendicular to tangent. Okay, so this is the radius of the inner circle. This is the tangent. Radius perpendicular to tangent. BP is a chord to the outer circle. BP is a tangent to the inner circle. BP is a chord to the outer circle. And it's a tangent to the inner circle. It's a tangent at D to the inner circle. Now, when you treat it as a tangent, this is the radius. BP tangent at D, so 90 degrees. And then when you treat it as a chord, BP as a chord, OD is a perpendicular from the center to the chord. So it bisects the chord. Theorem. So BD is equal to DP. When you treat BP as a tangent to the inner circle, OD is the radius and BP is a tangent. So radius, tangent, perpendicular. Now when you treat BP as a chord to the outer circle, OD is a perpendicular from the center to the chord. So it bisects the chord. So BD is equal to DP. So we find BD using Pythagoras theorem and double that to get BP, which is the length of the chord. So that's 4 plus 4, 8. So this is 3, this is 5. Pythagoras theorem, this is 4 because this is 90 degrees. So this is the hypotenuse. So 4 plus 4, 8. Correct. Okay, two concentric circles are such that the difference between the radii is 4 centimeters. Concentric circles. So let's just take a standard figure like this. I think chord and all that. So yeah. So concentric circles, they have the same center, but different radii. So you can see this line segment is the radius of the outer circle. And this line segment is the radius of the inner circle. And this is the, this line segment is a tangent to the inner circle and a chord to the outer circle. Two concentric circles are such that the difference between their radii is 4. So if we take this as R, this one will be R plus 4. If this is R, if the smaller radius is R, the bigger radius is R plus 4 because the difference is 4. And the length of the chord of the larger circle, which touches the smaller circle, is 24. The length of this chord is 24. The length of this chord is 24. So half the length of the chord will be 12. So this is 12. The difference between the radius is 4. So if the radius of the inner circle is R, the radius of the outer circle is R plus 4. And this is the chord. Half the length of the chord is 12. 24 by 2, 12. So connect all these three using Pythagoras theorem. R plus 4 the whole square is equal to R square plus 12 square. So R square plus 8R plus 16 is equal to r square plus 144. R square gets cancelled on either sides. 8r is equal to 144 minus 16. So 134, 124, 128. So r is equal to 8 ones are r is 16. What should we find? The radius of the smaller circle. Yeah, 16. Correct, children?
Yes, ma'am.
Okay. All right. Okay. So we know that parallel tangents are always at the ends of a diameter. Parallel tangents are always at the ends of a diameter. AB is a tangent to the circle at P. CD is a tangent to the circle at Q. So when you join the points of contact, it will pass through the center, and that is the diameter of the circle, and that will be the diameter of the circle. If two tangents are parallel, if you draw two tangents to a circle which are parallel to one another, then these two parallel tangents will be at the ends of a diameter. That is, if you join their points of contact, it will pass through the center. So if you join the points of contact, so AB is a tangent to the circle at P. CD is another tangent to the circle at Q. It's given that AB is parallel to CD. So if you join PQ, it will pass through the center, and PQ is the diameter to the circle. So POQ is 180 degrees. Yes, this is 180 degrees. PQ is a diameter. Yes, PQ is a diameter. True, true. APQ. APQ 90. PQD. PQD 90. Correct. So all of these children. All of these. Circle, if you take any diameter, and if you draw tangents at the ends of the diameter, they will be parallel to each other. Because radius tangent 90 degrees here, radius tangent it's 90 here. 90 plus 90 is 180. Co-interior angle supplementary. So the lines have to be parallel to each other. So here's all of these. If L is a tangent to the circle with O and M is passing through O, line M is passing through O, intersects the tangent L at the point of contact. It passes through, okay. So this line M, it passes through O, and it meets the tangent L at the point of contact. It not only passes through O, this line M not only passes through O, it also meets this line L at the point of contact. then L has to be perpendicular to M. See, if this line M just passes through O, it can be anything. It not only passes through O, it meets L at the point of contact. L is a tangent. It's given L is a tangent. A line M passes through O and it meets L at the point of contact. So then M and L are perpendicular to each other. No, they're not parallel because, see, they're not parallel because it meets, no, L meets, M meets L. So this one is ruled out. M, it meets L at the point of contact. So parallel, no. And angle 60 degrees. Okay, they meet, they intersect. Yes, they intersect and they make an angle of 60 degrees. No, because it passes through the center and meets it at the point of contact. So it is 90 degrees. So it is not this. Can't be determined. L perpendicular to M. So L perpendicular to M. This one is the correct option. Yeah. 3. Number of tangents that can be drawn to a circle from a point inside it. 0. No tangent can be drawn to a circle from a point inside the circle. No tangent can be drawn to a circle from a point inside the circle. Correct. Yeah, this one.
PQ is the tangent to both the circles.
Correct. PQ is a tangent to both the circles. Are the two circles concentric?
No, ma'am.
No, they are not concentric because they don't have the same center. This is the center of the smaller circle. Somewhere here may be the center of the larger circle. So they're not, just because they are one inside the other, they need not be concentric. Concentric circles have the same center but different radii. These are touching circles. These are touching circles. The two circles are not concentric. Okay, so this is the correct option. PQ is a tangent to both the circles. Because T is a point, the point T lies on both the circles. These two circles, they touch at T. They touch at T. T is a point that lies on the smaller circle and the larger circle. T is a common point to both the circles. And so PQ is a tangent to both the circles at T. Because T lies on the outer, T lies on the big circle, T also lies on the small circle. So T is a point which is common to both the circles. And PQ touches the circles at T. So it's a tangent to both the circles. So T is a point which is on the tangent, on the big circle, on the small circle. This point T is on the tangent. It is on the big circle. It's also on the small circle. Yeah, last one. A parallelogram circumscribing a circle is a
Rhombus, ma'am.
rhombus. It's a rhombus. How do we prove it's a rhombus? So say A, B, C, D.
Tangents drawn from an external point.
Yeah. So see here, we know this result, know that the sum of the opposite sides are equal. We know that we know this result that AB plus CD, the sum of the opposite sides are equal. AB plus CD is equal to BC plus AD. We know this. If a quadrilateral circumscribes a circle, the sum of the opposite sides are equal. AB plus CD is equal to BC plus AD. So what is AB made up of? AP and BP. And CD is made up of CR and DR. So write it carefully one below the other like this. See, you have AB and CD here, AB and CD, and AB is made up of AP and BP. So AP and BP, and CD is made up of CR and DR. Now complete this. AP is equal to AS, BP is equal to BQ, CR is equal to CQ, DR is equal to DS. Now when you add the results, you will get this one. Add these two results. So AP plus BP is AB. CR plus DR is CD. AS plus DS is AD. BQ-CQ is BC. But now it's given it's a parallelogram. We know that in a parallelogram, opposite sides are equal. So AB and CD are opposite sides. They're equal. So AB plus AB equals. Here also AD, BC, the opposite side, they're equal. AD plus AD. So we have twice AB is equal to twice AD. AB is equal to AD. Adjacent sides are equal. So in a parallelogram, if adjacent sides are equal, it's a rhombus. In a parallelogram, when adjacent sides are equal, it's a rhombus. We don't have to prove it. We just try to recall the proof. A parallelogram circumscribing a circle is called a rhombus. You were right. We just recalled the proof. So write this result. In the rough column, just write this result. The sum of the opposite sides are equal. AB plus CD is equal to BC plus AD. Write that. And now what is AB made up of? What is AB made up of? AP and BP. Then CD is made up of? Complete these results. Complete these results using the theorem that tangents from an external point to the circle are equal. So AP is equal to AS. All this. Sorry. So on adding, you will get this result. AB plus CD is equal to, when you add these two, you get BC. When you add these two, you get AD. Now, so this result is a general result. When any quadrilateral, it need not be a parallelogram. When any quadrilateral circumscribes a circle, this result is true. The sum of the opposite sides are equal. Now it's a parallelogram. So opposite sides are equal. That means AB is equal to CD. So you can write CD plus CD because both are equal, right? AB and CD both are equal. So you can write AB plus AB or CD plus CD is equal to BC is equal to AD. Opposite sides are equal. So you can write BC plus BC. So twice CD is equal to twice BC. CD is equal to BC. Adjacent sides are equal. In parallelogram ABCD, adjacent sides are equal. So it's a rhombus. Yeah, X plus Y 90. PBA is 50. So how much is OAB, children?
40.
40. So you can just draw it like this always. See. So this is the chord. Center of the circle. PA, PB, O. PBA is 50. This one is 50. So that means this is also 50. Now OAB, this one is 90. So 90 minus 50, 40. Yeah, ROQ 150 because it's a cyclic quadrilateral, opposite angles are supplementary. BAT.
55, ma'am.
Yeah, correct. You can use the alternate segment theorem or okay, answer this question, children. Is this 55? This is 55. Is this 55?
No.
No, we can't say. Correct. Because we don't, these two chords, only if these two chords are given to be equal, you can say this is 55. Because some, can you disable your mic? Yeah. So this is 55. This need not be 55, or we can't say now. Only in the triangle if you have the radius like this. If the triangle is made up of two radii like this. Sorry, children. Yeah. Only if the triangle is made up of okay, only if in the triangle two sides are the radii, then this angle will be equal to this angle. So not to get confused, you people know that, but not to get confused. Suddenly, no, like 55. So don't by mistake mark this also as 55. It is not. This is 55. This is 90. Why?
Angle in a semicircle, ma'am.
Angle in a semicircle is the right angle. So using angle sum property, you can find this. And that is 35. By angle sum property, this is 35. Now again, this is 90 because radius tangent perpendicular 90. So 90 minus 35, you will get 55. And that's a result by the alternate segment theorem. If this is 55, this is 55. You can see the chord. You can see the chord and the tangent. This is the angle between the chord and the tangent. Now this is the segment through which this angle passes. So the other part is the alternate segment. And you can see the chord, the ends of the chord, they meet at C. So this angle made by the chord in the alternate segment is equal to the angle between the chord and the tangent. So 55. Next one.
Thirty degrees.
Okay. A, B is 132. How much?
30, ma'am.
Oh. How 30? Read your steps, Danya.
Angle OAP is 90 degree, ma'am.
Okay.
So OAB is 90 minus 72, 18 degrees, ma'am.
Correct.
And then in triangle OAB.
No. If this is 18, this has to be 18. No, if this is 18, then this is also 18, right? That's what here also there's a mistake with the question. No, see, you'll get like two different answers. Agree?
Yes, ma'am. If we add 80 plus 132 and we get 30 degrees.
No, no, 1 minute. If you take 18 here and 18 here, no, the angle sum property of a triangle is not satisfied. 18 plus 18 plus 132, are we getting 180?
No.
No. That's what. Okay, so we'll not ponder much about this, children. So there is a mistake with the question. And also we don't need this information at all. Why do we need this? Why do we even need this to find ABC? So we'll just ignore this information. It's incorrect. The value given there is incorrect. So Danya, as you said, but I don't know why you got 30. So as you said, this is 90. 90 minus 72, this is 18. So this is 18 because radius, no, this triangle is isosceles. OB is equal to OA radius, so it's isosceles. So this is 18, this is also 18. So ABO is 18, which means ABC is also 18. ABO is 18, which means ABC is also 18. Okay, so 18 is the correct answer. Okay, so here you have to prove the result that AP is equal to half the perimeter of triangle ABC. Yeah, tell me, how do we prove this? To answer this question, you can remember this result. AP is equal to half perimeter of triangle ABC. And you can, like just calculate straight away like this, but let us recall this proof. Okay, so let me just tell you this. So in a figure like this, children, you can see that A is the external point of the circle. AP and AQ are tangents. AP and AQ are tangents to the circle from the external point A. You can see the triangle here, ABC. We can prove that AP or AQ is equal to half the perimeter of triangle ABC. Half the perimeter of triangle ABC. The length of the line segment AP or AQ, because AP is equal to AQ, is equal to half the perimeter of triangle ABC. Yeah. How do we prove that? So we start with the perimeter of triangle ABC. Perimeter of triangle ABC is equal to AB plus BC plus AC. Sorry, 1 second. Yeah, so BC can be written as BD plus DC plus AC. Now BD can be further written as BP and DC as So we split here, we split BC. Then we write BD as BP and DC as CQ. So now AB plus BP is AP plus CQ plus AC is AQ. So perimeter of triangle ABC is equal to AP plus AP you can take because AP is equal to AQ, right? So twice AP. So AP is equal to half perimeter of triangle ABC. Let's do this again quickly, children. Tell me. You tell me, I'll write. Yeah, hurry up. Yeah, next. What is BC? Okay, and then next.
BP, ma'am.
BP. DC is
CQ.
CQ. AB plus BP.
AP.
Very good.
AQ.
Yeah. Now AP and AQ are equal, so AQ can be replaced with AP. So twice AP. Very good. So this is the result, and we have to find AP in this question. First one, half into perimeter of triangle ABC. So 7 plus 5 plus 8, 20. So 10. 10. AP is equal to half the perimeter of triangle ABC. So half of 20, 10. Yeah. What's the length of AB, children? Next one.
15, ma'am.
15, is it? Okay. Okay, that's all is given. 3, D is 9. Okay. So the rest of it, nothing else is given. We'll have to find AB. Okay, children. So if this is 9, this is 9. If BD is 9, then BF is 9. And okay, we don't know AE or AF, so we'll take it as X. So now connect using Pythagoras theorem. So X plus 9 the whole square is equal to X plus 3 the whole square plus 9 plus 3 is 12, 12 square. I think when you work this, you will be able to find the value of X. And you have to find AB. So AB is X plus 9. This you can complete. We'll just do this again. See, BD is given 9. So that means this is 9. This is given 3. So you know this one is a square, so all over it's 3. This one is not given. Neither is this given. So we take it as X. So now, connecting using Pythagoras theorem, it's given here right angle triangle. It's not marked here, but it's given. Hypotenuse square 9 plus 3, 12 square. BD is 9, not BC. Only BD is 9. Okay, so yeah, X is 6. Correct. So 6 plus 9, 15 children. X is 6. And AB is 6 plus 9, 15. CD. So this is 4, so this is 6, this is 6, this is 2, so this is 2, this is 3, 3, 9, correct?
Yes, ma'am.
Okay. Because this is 4, this is 4. The whole thing is 10, so this one is 6. 2, so it's 2 here. So the remaining part is 3, 5 minus 2, 3. So this one is 3, so 6 plus 3, 9. So 80 degrees, right?
Yes, ma'am.
Yeah, because these two triangles are congruent. So this is also 40, so 40 plus 40, 80. These two angles are equal. 40, 40, so the BP is 80. So this figure is what is almost like a standard figure. You need to take a chord like this and draw the tangents, center, chord, and show the tangents, center, join like this. So this is the standard figure. In this figure, you'll have to mark the information given. Okay, so here PC, 7, right?
Centimeter.
7, because PA is equal to PB and PB is equal to PC. So 7, very good, all right. Now I'll I have the answers to the case study based questions from arithmetic progressions children. I'll present that PowerPoint live. Please go through. You can navigate through the slides. Check your answers and then we'll get back and discuss in case we have any difference in answers. Just give me a minute. I'll present it. Children, are you able to see the presentation on arithmetic progressions?
Yes, ma'am.
Yeah. So I've inserted my answer slides in the middle. Please, please check your answers. You can take screenshots also if you want to go through the steps later. I'm sure you've all got it right. But just in case you need to check more in detail, you can take pictures, you can take screenshots. For now, you can just see, check your final answer, and if something does not match, we can discuss now. So today's class might go up to 5 o'clock, children, because we'll just finish this and then wind up the session for today. We'll not hurry with this. I'll get back in 10 minutes. In the meanwhile, you check your answers, children. All of you are able to navigate through the slides, right?
Yes, ma'am.
All right, children. Completed, children?
Yes, ma'am.
Thank you, Navya, for always being there to answer my questions. All right, I'll just stop sharing and get back. Yeah, now it's again your time to ask me if you're because here I've worked the answers completely. We're not going to see it one by one. So now that you have the answers with you, you can ask me if there's a difference in the answers. You can just get them clarified now. Here also I noticed a few questions. 1 second, I don't. I'd given 2 answers for one particular question. Yeah. See, when it comes to the difference, see the question here. What is the difference between the number of seashells in the 19th and 20th cells? See, normally when difference between, see, if you're asked to find the difference between the 19th and the 20th cells, it is A19 minus A20 in this order only. In this order only. But when you work it in this order, you don't have the option. So you have to do A20 minus A19. Now see, if the question is find the difference between, or see, when we were in lower standards, find the difference between 10 and 20. Find the difference between 10 and 20 is 10 minus 20, not 20 minus 10. But when you work A19 minus A20 here, this option minus 3 was not available. So we have to do A20 minus A19, which is 3. See, they're not asking us to find the common difference. If it's a common difference, yeah, we have to do A20 minus A19. They're just asking us to find the difference. What is the difference between? If it's common difference, of course, it is A20. It can be A20 minus A19 or A5 minus A4. Difference between a term and its preceding term. So that's why I worked both the ways. So of course, you will be doing only this. You will be doing only this. This option is not there. So.
Ma'am.
Yeah.
Ma'am, in the third case, study third question, ma'am.
Third case study. Third question. Yeah. Right, here also. Correct. Even I had a problem there. Yes. Yes, Navya. Let me hear from you. I want to know if you also understood the way I understood. On the next day, she arranges X pairs in 15 rows.
In 15 rows means from the first row till the 15th row.
No, but so later, yeah.
So it should be sum of 15 rows.
Correct. That's what I've done, right?
Yes, ma'am.
Yeah, that's what. See, but I didn't. That option is not here. There's a problem with the. It should be on the next day. She arranges X pairs of shoes in the 15th row. Correct?
Yes, ma'am.
For this question, they're given the options. Yeah, that's what. On the next day, she arranges X pairs of shoes in the 15th row. In the 15th row. So in the 15th row, A15, there are X shoes. So the 15th term is X. A plus 14D is equal to X. Yeah. So here also. Total number of shoes arranged in 15 rows. Total number of shoes arranged in 15 rows as per the question given is X. So then X is 255. This is what is the answer as per the question given there. This is the answer. This is the answer as per the question given there. But the options are different. We don't have this option there. So you need to understand the question like this. No, in the examination, you will not, I don't think you will have a, like there'll be a misprint like this. This shouldn't happen in the exam. In the board exam, I don't think you will have a question which is incorrect like this. So here we'll take this because based on these options, it should be in the 15th row. So I've worked it here. On the next day, she arranges X pairs of shoes in the 15th row. Then X is equal to A15 is X and it's 31. Yeah, correct. Where else, children? Navya? So here the question was incorrect. And then this one, which I told you, required difference.
Ma'am, no doubts, ma'am.
Okay. So here if X, Y, Z are in AP, we know that Y minus X is the common difference. Z minus Y is also the common difference. So Y minus X is equal to Z minus Y. When you work this, you get the condition 2Y is equal to X plus Z. And then to understand the patterns here, if they are in AP, you can quickly work the common difference. Just work the common difference. That is, check if this term minus this term is the same as this term minus this term. You can make out on the face of it, or you can quickly work this. This one minus this one should be the same as this one minus this one. In that case, it's an AP. Otherwise, it's not an AP. Here also, this minus this should be equal to this minus this. Second term minus the first term should be equal to the third term minus the second term. So this is second term minus first term, third term minus second term. So when you work this, you get A2 minus A1. A2 minus A1, you know, is D. Because it's given here. A1, A2, A3, AN, they are the terms of an AP is given here. A1, A2, A3, AN, terms of an AP. So that means A2 minus A1 is common difference, D. Second term minus the first term, you get A2 minus A1, which is D. Third term minus the second term, we get A3 minus A2. Third, A3 minus A2 is what here? What is A3 minus A2? D only. So we get the same value. So it's true. The first sequence forms an arithmetic progression. And the second one, second term minus the first term, third term minus the second term. We get A1 minus A2. And here we get A2 minus A3. What is A1 minus A2? What is A1 minus A2? It's minus D. What is A2 minus A3? Minus D. A2 minus A1 is common difference. A3 minus A2 is D. A1 minus A2 will be minus D. A2 minus A3 is minus D. So A1 minus A2 and A2 minus A3. So it's minus D. However, the value is the same. You don't have to get D. The difference is the same. You're getting minus D here. The second term minus the first term is minus D. The third term minus the second term is also minus D. It's the same. So the second sequence, this sequence also forms an arithmetic progression. Because its second term minus the first term is the same as its third term minus the second term. Here also, this term, second term minus the first term, then third term minus the second term. A2 minus A1 is D, A3 minus A2 is D. So you get K into D, K into D. So it's the same. So in the sequence also, the second term minus in the sequence in C, the second term minus the first term is the same as the third term minus the second term. So here also the sequence forms an AP. So all of these is the correct option. All of these. So since Sn is given to find Sn minus 1, in place of n, you will have to use n minus 1. Sn is given. In place of n, use n minus 1. Sn is this one. So Sn minus 1 will be 0.1 into n minus 1 the whole square plus 7.9 into n minus 1. Replace n with n minus 1. See this n with n minus 1, this n with n minus 1, this one with n minus 1. Find the radius of the core. So for that, you'll have to find S1. The terms here are the diameters. Here, you know, we have concentric circles. This tissue roll can be understood as concentric circles. So the diameters of the circles starting from the roll inside. A roll is that hard thing, you know, around which the tissue is wound. A roll, when they say, sorry, that the middle portion. Excuse me. Yeah, thank you. See the terms here, core and roll, core and roll. The core is that hard thing, you know, that once the tissue is exhausted, you can see that hard thing, you know, that cardboard cylindrical thing. That's the core. The roll is the paper, the tissue paper, which is rolled on it. The terms of the AP here are the diameters. Starting from the core, the diameter of the core is the first term. Then the tissue paper is wound on it, no? That's the diameter of that tissue paper, that cylindrical tissue paper. That's the second term. If you can see here, from here, diameter. Sorry, this is the diameter. The diameter of the core is the first term. Then just imagine the tissue paper wound over it to form a cylinder. The diameter of that one is the second term. Then again, it continues. The tissue paper is rolled further. So that second cylinder formed, the diameter of that is the third term and so on. Yeah. Yeah, children. So the first term is the diameter of the core. The second term is the diameter of the tissue paper, which forms a cylinder. The diameter of the tissue paper, which actually is a cylinder. The diameter of that one, that first cylinder formed by the tissue paper. The first diameter is not the diameter of the tissue paper. That's the diameter of the core, that cardboard. The first, the first cylinder which is formed using the tissue paper, the diameter of that one is the second term. Then again, when the tissue paper is further wound, you get another cylinder. The diameter of that cylinder is a third term, and so on. So the diameters here are the terms of the AP. So radius of the core. So which means you'll have to find S1 using this, find S1. And S1 is A1. S1 is A1. Sum to one term. There's nothing but the first term. But that's a diameter. The first term is a diameter because the diameters form the AP. So half of that is a radius. So find A1, find S1. Using Sn, find S1. S1 is A1. And A1 is diameter of the core. So the radius of the core is half of it. S2, you know, in Sn, find S2. Using Sn, find S2. Yeah, what's the diameter of the roll when one tissue sheet is rolled over it? What is the diameter of the roll when one tissue sheet is rolled over it? So you should find the second term. You must find the second term because the diameter of the roll when one tissue sheet is rolled over it. The first term is the diameter of the core. So this is the next one. So you should find the second term. We understand that the diameters form the diameters form the terms of the AP. So when the first tissue sheet is rolled, that's a second term. So we should find A2. So we'll find S2 and then find A2. So we already have S2. I think in this one we have worked S2. Here we have found S2. We have found S2 here, which is A1 plus A2. What is S2? Sum of the first two terms. So that is the first term plus the second term. S2 is the sum of the first two terms, which is the first term plus the second term. So we'll use the answer we got here, S2. So S2 we already worked. Okay, it's 16.2. So A1 plus A2 16.2. A1 also we found earlier somewhere here. Yeah. So A2 is 8.2. This is the diameter, and the question is to find the diameter only. So you don't have to find half of this. The terms are diameters. So 8.2. Then the thickness. Thickness is this one. Thickness is this one. So that will be the radius. Radius of this one minus the radius of, that is the radius of the outer circle minus the radius of the inner circle. Thickness will be, the thickness of each sheet will be the radius of the outer circle minus the radius of the inner circle. So the radius of the core is 4. The radius of the core is 4 because 8 by 2, 4. The radius of the tissue paper following that is 4.1 because 8.2, no, by 2, 4.1 radius. So thickness is 4.1 minus 4, which is 0.1 centimeters or 1 millimeter. Yeah, any further questions, children? Sashank, Raja, Navya, Florentina, and Trishrutik. Any questions?
No doubts.
All right. So with this, children, we saw the answers to all the case study questions from circles and arithmetic progressions, which we had taken up yesterday. And today's session, so like in the classes to come, I'll keep the answers ready so that, we don't have to postpone the discussion. Like yesterday, I was not well. Otherwise, I would have done it in the class yesterday itself. But the time taken is the same. Like we have not spent longer time on anything. Maybe if we discussed yesterday, we would have done circles yesterday and AP today. But since we didn't discuss yesterday, you did both yesterday and we discussed today. So we have not, like taken extra time or wasted time anywhere. It amounts to the same thing. But I'm just telling you that in the classes to come, we'll be discussing the answers then and there in the class itself. It won't be postponed to the next session. All right. All right, children. So that's it for today's session. Thank you so much. Before you leave the call, we'll be continuing with the special classes next week. So kindly check WhatsApp for that. The next regular class is on Thursday. But before that, you might have 1 or 2 special classes from 9 to 10 or 9:30 to 10:30. Please check WhatsApp. I'll update there. Yeah. Thank you, children. You may leave the call.
Thank you, ma'am.
Thank you, children. Thank you.